Hello and welcome to this video overview of CADS Masonry Wall Panel Designer Max. I'm going to give you a brief introduction and go through some key features, then show you some examples. The program was first released in 2006 as a development from an earlier program, CADS Masonry Wall Panel Designer, which was released back in the 1990s. CADS Masonry Wall Panel Designer Max is used to check the structural capacity of rectangular wall panels in accordance with either BS 5628 or Eurocode 6. The concept design can be quickly input, checked, and then within the same project file, altered to check alternative designs, or if the wall cannot be easily designed or conceived by traditional methods, then the program will assist the user to get the wall to pass with the many advanced optional features that it provides. The program allows the input of openings, the size and location of these openings within the panel. There are three types: internal, adjacent panel openings, and unsupported edge openings. These model doors and windows. Adjacent panel openings are where you have a panel adjacent to the one you're looking at, where any openings in that may reduce the moment of resistance across their common edge. And then an unsupported edge opening where you've got a door or window where the wind load on those objects may apply a load to the unsupported edge of your panel. By including these openings, the designer can avoid the need for expensive wind posts required in the past when designing such panels was difficult by hand, and thus cutting the cost for the client. The program has built-in proprietary products, including bed joint reinforcement and ties. These include companies such as Beckert, Ancon, and Murphy. The program is quick and efficient, of course, and is widely used. Nearly all local authorities know of this program. It's trusted, tested, and respected. As mentioned, the program can design to either BS 5628 or EC6. In fact, you can switch from one code to the other within the same set of data in the same file, so you can compare results, or you may even be asked to change your design code during the proposal project. The wall type can be single or cavity, with sections either plain, piered, fin, or diaphragm. There are built-in libraries of brick and block, DPC, damp-proof coursing, bed joint reinforcement, and wall ties. These can either be used or edited to suit your own. You can actually input some of these things yourselves. It's an open library you can add to. Openings are included, as well as a wide range of different support conditions that can be specified on each supported edge, either as pinned, fully or partially fixed. Line loads can be applied either on the wall laterally or vertically on top from, say, a supported slab. Uniform and trapezoidal loads can be applied to the wall from either direction to model either wind loading or piles of material, and these can be applied internally or externally. Load combinations are automatically created, combining up vertical and lateral loads, but the user can either edit these or input your own combinations if you wish. Walls will be analyzed as cracked or uncracked. This really depends on the nature of the wall you're designing, but we find most local authorities would require a cracked section analysis for more conservative results. There's ultimately then a choice of output in terms of content, diagrams, and volume. You can control the volume. We have three settings: summary, concise, and detail. A summary option would give you a single, possibly 2 pages of output in Word or PDF format. Okay, so let's have a look at the program. Okay, so I've opened up fairly straightforward looking wall to start with. I just want to go through the program and show you how we navigate through it, what all the options are, so you can see how the program might be able to help you and what all the variations are. Down the bottom, we've got the main input screen here, which you can go through just next and back chronologically, probably how you'd start. And then when you've put the whole wall in, you may want to skip back to the masonry or the geometry to change it, and you can do that through the side menu here. You can also navigate across the top, like so. The code options are here, so you can set it up for the British code or the Eurocode. And in the Eurocode options, you can set it to Irish Annex, General Eurocode, or UK, with user-definable options as well. You can then choose single or cavity leaf, and you can see the diagrams reflect what's going on. If you choose cavity, you get this near and far option. Now that's just as long as you're consistent through the program, and the results, it's not difficult. Near, we've got as the brickwork, and far as the block. The program asks you what those definitions are all the way through, and then in the results it will give you the loads in each leaf separately, so you're consistent, you'll be all right. You can also see I've got them unticked at the moment. I've got other examples I'll show you later, but we've got paired fin diaphragm section if you want, Wall openings here we can turn on, bed joint, and I selected wall ties and lateral wind loads for now. So then we just tab through. I've got the geometry, height and width, and brick and block width. The masonry types here. Anything you fill in this screen here is changing the characteristic strengths in the background. And again, if you want to, you can go user define and put your own in directly. But this is working to the code. So for instance, we've got here, for instance, vertical joints, filled status, either filled or unfilled with close, as you can see there, with close butted perpendicular joints. So if you look at the perpendicular joints, it gives us a 0.26 limiting shear. Whereas if I change it now to a rather new method of construction where you've got these great big blocks where there's not much mortar, you can see that's changing the shear strength to 0.18. So that's just an example of where the choice of joints fill makes a difference, as well as the mortar type up here. This will also change the characteristic strength, flexural strength. So going down the list, and you can see we've got the masonry units themselves. Again, user defined or from the library. Very comprehensive set of standard masonry units in here for block and brick. You can see that as you expand it, you can see all the different types. And not to worry, if there's anything missing, and we do try and keep this as up to date as possible, you can see all the details of that type of brick over here. If you want to, you can copy and create your own or put a new one in entirely. So it is an open library. Okay, so just tabbing through. You can see we're down to supports here and masonry is there. Look, so you can just see how you can navigate through two different ways there. You've got the support types. Now, the hatching means that we've got a support of some kind. And the double hatching means it's fixed. So if you see here, I changed this to simple. You can see it's changed to just a single hatch. So that's continuous. Continuous is obviously a moment connection. Simple is just taking shear. And if you're not sure, then you can use partial. So anywhere between 0 and 1 gives some percentage of utilization. So 20%, 30%. That's 50. So you can do what if calculations. If you're not completely sure, you can see how sensitive the results are to the different quality of workmanship or connection types that you've got. And these can be of any type of connection. We can have top free, we could have bottom and left-hand side only. So there's quite a comprehensive set of conditions you can put in here that don't often get covered by the code. You can also see the option for DPC at the bottom here. So what the program will do is work out the strength of that leaf edge here based on the DPC or the mortar itself, whichever is weaker it uses. And it's having ticked it on, it's then prompting me in the next screen for what that will be. This DPC is turned on. If you see I untick it, it's gone. So that's how the menu on the left-hand side is expanding. And then here we've got the effective height, details of how that's calculated. And this will vary depending on the support conditions here. So it's looking at stability. In the next screen, the DPC, as I've just said, different types. Again, copy and edit, so you can put whatever you wish in. The wall ties themselves. Now, I've ticked that on. Two different types. The cavity ones, so this is tying the two leaves near and far together. And you can see I've got type 2 there, hence the little numbers there. Look. And then we've got panel edge. So these are the ties around the edge on the brick and the block. So the cavity one's fairly straightforward. You choose which types you want to use. You've got details here of compress and tensile strengths, and copy and edits again available. And you can put in the pitch, vertically and horizontally. And then you've got panel edge. The program's got these buttons here to save you time if you want the wall to be the same or the far to be the same as a near. Let's say on our far side, we've got bonded masonry left and right. That means it's tying into an existing wall or pier, for instance. And then we've got masonry shear top and bottom. So that's assuming there's some kind of beam there it's actually attached to. And then near leaf, I've got tension and compression ties, left and let's say left and right. And then we'll use masonry shear top and bottom. So you can mix it up as much as you like. There's even an option here to say that you've got support from another leaf. And that's tying in. So rather sort of set of options there you won't be too familiar with. And for that reason, I'm just opening the help screen here. You can see definitions of how the ties work in terms of what the scope is. And then here we've got the different types, how they work, and some rather useful diagrams here. This is showing what bonded masonry means in terms of the leaves. You've got here the near leaf. This leaf is with a tension and compression tie, but on here you've got a bonded connection. And then here is the shear connection. So you've got a column or a beam, and you've got a shear connection between the leaf and that. And then this side is just tension compression. Then you've got the support via other leaf, where the ties are connecting your wall to an existing structure like a wall or a beam or a column. And that's the option I ticked as yes or no. Do I have another leaf to tie to? Okay, and again, these can be set out with, on the near leaf here, we can set those out at varying pitch. And you can see the extremities there. The program will actually check those ties for capacity. You'll see that later on. Then we've got the partial safety factor input. Now this is asking us questions from the code. So it knows what partial factors to set for ULS and SLS and material strength. We've got it to the British Annex. So we've got choice of 1 and 2 execution class. In the general EU code, that'd be 1, 2, 3, 4, 5. Just to show you what I mean, that's set to class 2. So we've got a flexural and compression strength here of 2.7. But if I set it to 1, the flexural tension and compression strength's gone down to 2.3. So that's the class of workmanship, the execution class. So that's pretty standard, set at 2. Then you've got the risk factors for lateral pressure and stability, which are affecting such things as the lateral pressure factor there, look. So if I change this to factored, you can see it's altered the factor here. And then over here we've got some vertical imposed and lateral load options and the use of these loads in the building, where they've come from, what type of structure it is. This is so that if they're not the leading variable, it knows what psi value, what psi factor value to use. Okay, finally we get to the loads. Now we've got wall finishes and openings we can add. In other words, not just self-weight, but we want to add some extra load from finishes. And they can be applied to either leaf or just a single one. Vertical dead and imposed loads, vertical wind loads, that's described here, where you've got the wall attached to the roof and it's giving you some pressure and suction. You can include that. Over here we've got lateral loads, and they can be either wind loads, which is what I've got here, or later on I'll show you pressure loads and line loads. So varying types. And then all you do is fill in the various options for the bits and pieces that we've just chosen. So we've got wall finishes there. So we're going to have a little bit of extra on the far leaf. We've got vertical dead. So we can put in here vertical dead. And then over on the vertical imposed, we can see on the far leaf we've got vertical imposed. So we can have live far leaf. So I'm just putting in here a little description. You can see there, what I should put dead far leaf. You can see, just get rid of that one and put another one in, dead far leaf. And these descriptions come up above. You can see above there, dead far leaf, and you've got the imposed load here, live far leaf. Just tidy this up. There we go. And you can see the values up here. And then all we have to do is put the numbers in. So for the far leaf, we'll have, I don't know, 10, say. And then on the vertical imposed, we'll put in something like 8. And we can even add an eccentricity. Let me just put in 50 mil here. You can see that's from the centroid of the blockwork there. It's offset by 50 mil. And indeed, if you put in negative 50, you can see it goes the other way. So that's quite useful. There we go. And then wind loads, all you have to do is put in wind near. These are just descriptions in the program to help you save some time. Wind near, wind far. Just put in some values I'm thinking of here, 0.5, 0.6, say. And if you obviously want the wind to go the other way, we just change the factor there, look. So we've got wind on the near, wind on the far. And the program checks for all these loads on each leaf separately and gives you the worst case. We've also got over here the ULS and SLS combinations. These are automatically produced. If you don't want to, you can do them yourself. And indeed, if it produces these for you, you can see all the combinations here. Look. There we go. You can see the abbreviations, dead, live, wind on the near, wind on the far, and so on. If you want to, you can change any of the factors yourself if you need to, or remove them, or put extra ones in yourself. So it's all very open. Okay, then we've got calculation options. So we're going to do a vertical check for capacity. I've got this set to cracked because that's the most conservative. You can say uncracked if you wish. We've also got dimension checks. So slenderness check ratio, you may not want to do that, but I want to check the dimensions are okay within the limits of the code. So I haven't got too big a wall. I could also say I want to check deflections, and you can put in values here you want to check against for deflection. Right, there we go, and we've run that, and as you can see here, we've got a pass. If you go down the list here, look, you can see all the checks it's doing. These are just a brief summary, then you go into more details across the tabs here. So pass is the overall status. So no matter what's sort of tucked away down here, you'll always see that it's passed or failed here. This is our lateral capacity. So we've got 1.3 we can take, 0.75 we've got, so it's 54%. And that's the worst combination. As you go down, you can see here the vertical load capacity on the near and far. I put all the load in here, look. Then you've got the edge ties, cavity tie check, limiting dimensions, and so on. Yep. Going across, we've got common results. These are things like dimensions and so on. It's worked out. I values, support values. You can see here minimum thicknesses, utilization, therefore. Just checking against the code for the sizes of wall we put in. You then got ULS results. So you can see here results at the top, the center, and the bottom of the wall. You can see it does give you the loads at half height and full height and at the bottom. And SLS results. Obviously, these are the deflection checks that we just did. And any warnings. Then you go on to the output. You can have a material and design output. If you just choose summary, you get that single page, one page and a little bit. Depends on the type of wall you've put in, but it's keeping it as tight as possible. We're trying to obviously keep the output down as much as possible. There we go. As you can see, all on a single page. I'll zoom in a little bit. There we go. You can see the data. That's the wall we put in. And just going down the page, you can see pass on a single page. The alternative would be some diagrams, materials, concise report, or even detailed. Over here, if you've chosen detailed, you can even choose lots of various other items that you can put in. So you can choose all of it or some of it and really produce a very detailed document. So a concise report is similar, but more pages. And you can see I'm going through them here, look. Okay. And this can all be produced in Word or PDF format. Okay, let's have a look at another example. Okay, I've opened up another example, similar size wall, but I've this time got openings in here, which is what, as I said earlier, was the benefit of the program to avoid wind posts and splitting into subpanels. We can do a whole masonry panel within the limits of the size for the code, but we can include as many openings as you can get in there. The program's limited to 50% of opening area to area of wall. So it can't be totally covered in openings, but certainly within this kind of limit, it's not a problem. The program to do openings, as you can see here, if I go to the openings input, is using a yield line theory in the background to work out the moment of resistance of the panel edges, the reduction of the capacity. So it's described here in the help screen, and there's some various references to it in the help menu when you get the program as well. The other types of openings I've got here, you can see these little squiggles here. These are meant to indicate where we've got openings in adjacent panels, top, bottom, left and right you can put in. I've got some at the top here at different pitch from the edge here, and over on the left and right, and same on the block. So the difference here is that I've ticked on the box wall openings. That gives me this menu item. You can do this after you've designed a wall and put them in afterwards. And I've put a couple of wall openings in here. Look, these are internal openings for a doorway and a window. You can see the size and position. And then the adjacent openings here, if you see this one on the left, you go to the tab left, that's the opening size, distance offset from it. So opening height and so on. There we go. So you just need the opening height, which is obviously this distance here. And what that's doing, it's working out the reduction in the moment of resistance, basically the capacity of the wall, by virtue of the fact that this opening is reducing the amount of mortar and brickwork that's there. And I've done that for the right and top. Okay, so let's go through to the results and see what's happened. Now, in this particular case, you can see I've got a failure overall. And going down the list of all the checks I showed you earlier, you can see all these checks here. Nothing wrong with the dimensions and so on. It's the actual lateral load capacity. So this is the capacity and that's the loading. So I've got a problem there. Just have a look at the loads I've put on here. You can see them. There we go. So I've got some impose and dead loads on the block work, and I've got a wind load on the near and far, and then we're getting this result. So to get this to work, we need to strengthen our wall several ways, make it thicker, different brick. But I want to introduce the concept of bed joint reinforcement. So I'm ticking that box on, go to the input screen, and you can see the option here. Now we can put these in, the bed joint reinforcement in either wall or both, and then we can choose what type of materials we want, and we can say both are the same. So we can go into our library and choose whichever type of reinforcement we need, or indeed which manufacturer. So we'll start off with sort of general approach, like so, and then go to our results and see what's happened. So there we go. So we can see it's gone down. That was 1.2 something, so that's gone down a bit. So we've got away with a bit more there. You'll notice there is no vertical check here, or at least I'm pointing it out to you, and that's because the program won't do the vertical check until I get the lateral load capacity to work. So this is still not working. Let's go back to our bed joint reinforcement and possibly choose another brand or a different size. So we can go to Beckert or Ancon and choose one of theirs. You can see the strengths here. Go OK, and then go straight to the result. And there we go, we're working. We're 10% in. That's 91%. So the lateral load capacity is sorted out. Now let's see what else is causing us a failure, because it's got to be the vertical load check now. There we go. You can see that check now is failing. That's the capacity and the load. It's well out. So my first instinct would be to strengthen the wall. So I'm going to put in 140 block. Just have a look and see how much work that's done. You can see now we're getting there. We're definitely getting there. The other thing we could do is change the type of masonry unit. So let's go to our block. We've got Celcon here as standard. Let's go to the 7, which is a bit stronger. And have a look. And there we go. We've got it all to work. In fact, our lateral load capacity is coming right down now. We can maybe thin the wall up a bit, but the vertical load capacity is okay. And you can see the other checks it's done on the limiting dimensions and deflection. Okay, another example. Okay, so what I've got here is a single leaf, and you can see it's 4 meters by 2.5. It's a little retaining wall in block. I've got lateral pressure loads on here instead of the uniform wind loads, so everything's the same. Just go down to the load combinations here. Look, you can see the load option I turned on. Got finishes, vertical dead loads, and so on. But I turned on pressure loads rather than uniform loads, and here you can see the pressure load that I've put on here. So it's basically varying from 0 to 25. It could be whatever pressure you've got from your soils or fluids or whatever you've got there, and then a combination of imposed and dead loads above. You can see those loads all here in the combination screen too. And then ultimately do a check, and you can see we've got the lateral capacity, vertical capacity checks and so on. Going down there, the slenderness ratio it's looked at, limiting dimensions and deflections. Yeah, final example, we'll look at a load-bearing diaphragm wall. So we've put in single leaf. I've turned on the option to make it pier, fin, or diaphragm. I've got some wall ties. The wall ties in this instance are actually between the web and the flange here. So you can put that in, and then you've got lateral wind load. So let's go to the ties just to show you what's happened there. So I've got masonry shear, and then that's the panel edge. But then between the webs here and the flange, you can see I've actually got single ties in there just to tie the whole diaphragm wall together. And those are the types I've used. And then you go down to load options. I've put in a lateral wind load, some vertical dead loads, and so on, just as before, like you can see here. Just got some wind load on one side. Vertical capacity check. And there's all the results. Okay, so that's basically concluding the presentation of the program CADS Masonry Wall Panel Designer Max. Nice quote here from one of our clients, reflecting basically on the fact that the program gives him a lot more benefit when changes are made. As you've seen in the program, getting it right first time is not so easy, and the program lets you choose multiple different ways of getting walls to pass. In fact, that's what most of our users say, that the program is very good at getting walls to pass. They wouldn't have expected to in any other way. We've also got some other masonry design software here, part of our masonry retaining wall designer suite here. There's a general retaining wall program for concrete, masonry and gabions, but the masonry part includes 3 types of masonry wall here. You can see cavity, pocket, you can see the reinforcement pockets there, and then block, all in reinforcement you can put in, and the program checks and designs. There's some typical output. So that's something else you might want to look at. There are some videos of that, but if you'd like to contact us about that and anything else you've seen here today, just give us a call, send me an email. The team here will get back to you as soon as possible, and there's a website there where you can go and browse any other details you're after. It's my job to thank you very much for your time. I hope that was useful for you, and have a good rest of the day. Thank you all very much.